Okay, let's do problem 417. Two quality control technicians measured the surface finish of a metal part, obtaining the data in table 4E.1. Assume that the measurements are normally distributed. Test the hypothesis that the mean surface finish measurements made by the two technicians are equal. Use alpha equal to 0.05 and assume equal variances. Part B, what are the practical implications of the test? In Part A, discuss what practical conclusions you would draw if the null hypotheses were rejected. And Part C, assume that the variances are equal. Construct a 95 confidence interval on the mean difference in the surface finish measurement. So now let's take a look at the table provided. We have technician one. Let's see here. We have 1, 2, 3, 4. 7. So we have N1 is equal to 7 and N2 is equal to 8 data points. Since I don't have any information, okay, so now test the hypothesis. So we start by stating what is the hypothesis. We want to see if the performance of the first technician is equal to the second technician. So the alternative would be a two-sided mu1 not equal to mu2. And this can be written as H naught u1 minus u2 equal to 0, and the alternative mu1 minus mu2 is not equal to 0. Okay, now we need to identify what is the appropriate test statistic. Since no information about the population variances is known, so we are going to be using the t-test for two independent populations. So I have here T naught is equal to x1 bar minus x2 bar minus the hypothesized value, which is 0 here. So minus 0 divided by the pooled standard deviation multiplied by 1 over n1 plus 1 over n2. Okay? Excuse me. Now we need to calculate what is the pooled standard deviation. So first let's calculate the pooled variance. So let me do it here. So the pooled variance is equal to, and which is basically what? It is a weighted average of the two variances. So I have the first weight is n1 minus 1 times s1 squared, which is the variance of the first sample plus n2 degrees of freedom of the second sample multiplied by the variance of the second sample and divided by total degrees of freedom n1 plus n2 minus 2. Now I already calculated the variances for each one of the sample. So I have here n1 minus 1, that is 6 times the variance of the first sample, which is 0.0132 plus n2 is 8 minus 1, that is 7 times the variance of the second sample, which is 0.0139, 0.0139. Okay, of course, divided by n1 plus n2 minus 2, and that is 7 plus 8 minus 2, that is 13. So this is my total degrees of freedom. So now I have the pooled variance. Let me calculate it here. So we have 6 times 0.0132 plus 7 times 0.01 39, all divided by 13. So this is equal to 0.01357. Okay, and now to find the full standard deviation, I simply take the root of 0.01357. So let me do that, which is equal to 0.1165. Okay, so now that we calculated the pool standard deviation, we go back to this equation here. So let me put in my values. I calculated also the mean of each sample. So the first sample, the mean is 1.383 minus 1.371 minus 0, and we divide by the standard deviation, the pooled standard deviation, which is 0.11, just calculated 1165, multiplied by the square root of 1 over n1, which is 7, plus 1 over 8. Okay? Now the test statistic you would have is 0.19. So let's see now. Continuing, let's do it here. So this is 3 now. Okay, so now to identify the critical values and therefore the acceptance and rejection region, we are going to, this is a two-sided, and we want to, alpha is 0.05, so this is T 0.025 with the degrees of freedom. Total degrees of freedom is again 13, and this is minus T alpha over 2.025 with degrees of freedom equal to 13. Now we need to find this from the table. So I got the table here. So this is alpha over 2.025. And here the degrees of freedom is 13. So I'll get my critical values is 2.16. So the critical values are 2.16. So let me go back here. So this is equal to 2.16 and minus 2.16. Okay, so now the test statistic is 0.19. So down here, and this was in the acceptance region. So this is T equals to 0. In the middle here, I have acceptance region. To the right here, I have my rejection region. And from this side, also my rejection region. Okay. So now, since the test statistic T naught falls in the acceptance region, we fail to reject H naught. Therefore, mu1 is equal to mu2, and we conclude that the performance of the two technicians, that the performance or the measurements of the two technicians are the same. Okay, so now part C here, assume that the variances are equal. Construct a 95 confidence interval on the mean difference in surface measurement. So let's do it here. So basically here I'm going to have mu1 minus mu2 is less than or equal to x1 bar minus x2 bar, okay, plus T alpha over 2 with the degrees of freedom. So that's N1 plus N2 minus 2 multiplied by the pooled standard deviation multiplied by 1 over N1 plus 1 over N2. And from the other side, I will have x1 bar minus x2 bar minus, so this is between two brackets here, minus T alpha over 2 with the degrees of freedom, N1 plus N2 minus 2 multiplied by SP by 1 over N1 plus 1 over N2. Okay, so if you want, we can write the values here. So this is mu1 minus mu2. X1 bar is 1.383 minus 1.371 multiplied by T alpha over 2. Now T alpha over 2, again, the same value we used for the critical values, 2.16. 2.16 multiplied by SP. The pooled standard deviation is 0.1165 multiplied by 1 over N1, which is 7, plus 1 over N2, which is 8. So this is one side. Now let me do the other side here. I have x1 minus x2, 1.383 minus 1.371 minus T alpha over 2, which is 2.16 multiplied by the pooled standard deviation 6.5 multiplied by square root of 1 over 7 plus 1 over 8. Okay, I leave that for you to calculate.